Hi everyone, my name is Banghua. I'm co-founder CTO of RadixArk. So today I'm going over what we do at RadixArk and our journey towards building open source. So first, what is RadixArk? So RadixArk is a new startup where we work on infrastructure. And we work on open source infrastructure, and we aim to democratize access to the frontier level AI infra to everyone. So essentially, our mission is to make sure we build open source and then make them the best open source inference and training engine and make them accessible to everyone in the world. So we're building open source SGLang, which is our open source inference engine, and also Miles is our enterprise-grade RL training engine. So in this talk, I'll go over an introduction of both SGLang and Miles and how they work together with a broad AMD community here. So part one will be SGLang. So SGLang is an open source serving framework where we serve not only just language model, but also vision language model, diffusion language model, and across different stacks. And you can easily launch any open source model with just one command in SGLang. And it supports AMD, NVIDIA, like TPU, among others. And it has been used in production for a lot of different open source models among a wide range of partners, including XAI, AMD, Intel, LinkedIn, etc. So behind SGLang, there are a lot of techniques developed and improved in the past few years. So Redis attention is one of the very beginning techniques that come with the first SGLang paper, where it's specifically designed for prefix caching, so that for agentic tasks, people can reuse a commonly shared prefix hash for better efficiency. And there are also other techniques like continuous batching and also GPU graph optimization, where you're able to enable pre-config operations to speed up the entire launch process. And there are also techniques like chunk prefill, specific decoding, and especially recently, people are more focusing on disaggregated serving, where you can separately optimize the prefill part and the decoding part. So at SGLang, we provide first-class support with AMD chips. And there are more than 70 nightly CI tests running for the latest AMD hardwares to ensure stability and accuracy when serving with AMD hardwares. So there are support for all different hardwares from MI300X to 325X, 350X. And we also are benefiting a lot from different AMD-provided software like ROCm and latest ROCm version, and also different kernel backends where ITER is something empowered a lot of efficient SGLang inference a lot. And we're also using other kernel library like Tireland, Triton, etc. So we provide easy packaging where you can either directly use a Docker, or you can do pip-well and then build from source. And if you want to customize, every code here is open source, so that you can always customize your own inference stack for your own hardwares, for your own models, etc. And we provide and enable most of the day zero open source model support on AMD. We're recently enabling DeepSeek family like Qwen and GLM, Minimax, Kimi, etc. And each model all ships with a bunch of accuracy tests, performance benchmark, and also nightly CI to enable their efficient and also accurate in all servings. And we're also exploring diffusion model serving on AMD, where SGLang diffusion is a new project where people focus on enabling diffusion inference here. And it's worth noting that with the recent release of DeepSeek v4, there have been a lot of innovation in model architecture, including the hybrid attention with sliding window attention plus compression. So SGLang has introduced a lot of new innovations there, including a new Redis attention called Shadow Radix, and also a lot of context parallelism support for long context agentic tasks. So we're working closely with AMD to enable most efficient inference here with all the new techniques introduced in SGLang for DeepSeek v4 support. And it's especially optimized for long context agentic tasks, which is perfect usage for recent open cloud-related agentic task inference in those cases. So for part two, I'll be briefly talking about Miles, which is another new framework we have been introducing for enterprise-grade RL training. So in some of the morning session today, people have already dived deeper into how Miles is supported on AMD. Here, I'll give a brief recap and also provide more broader picture on the roadmap of Miles in general. So what is Miles? Miles is an open source RL framework where we aim at solving and improving the problem of large-scale LLM post-training, especially with a focus on latest hardwares on large MOE models. So Miles essentially is a glue of inference engine, which is SGLang, and also training backend, which is right now Megatron LLM, and also FSDP2, etc. And it's orchestrated by Ray so that we can make sure SGLang and also Megatron, the training backend, can be efficiently coordinated. And its sister project, Slime, is precursor, and Miles is a fork of Slime, which enables the training of all the GLM series. And then it right now supports most of the popular RL algorithms like GRPO, PPO, etc. And it also comes with a lot more new features for agentic training, especially in multi-turn agentic training, in async training support, and also a lot of other new features in low precision, etc. Essentially, you can view Miles just a combination of two-plane architecture. So one is a rollout engine, where we keep using SGLang for the most efficient rollout. And the other part is training engine, where we use Megatron or FSDP for backward. And Miles provide all the support to actually make sure those two are coordinated the best, so that you can make best of your hardwares for all the training support here. And because Miles is designed in a very modularized fashion, so you can easily swap your favorite training and inference backend without too much effort. So that's also one reason why Miles was able to enable DeepSeek v4 day 0 support in training, just by integrating SGLang's DeepSeek v4 0 support, along with the more patches on Megatron side. So Miles has some key features that we'll keep developing. And so on the training side, we are supporting a bunch of new and past popular IO algorithms like GRPO, PPO, etc. And then we're also recently more working along the line of inference training alignment, where the inference kernel and training kernels may not be matching, which leads to a difference in the training engine's output and inference engine's output. So we'll dive deeper into that in the next few slides. And there are also other new features like routing replay, which is very important for stabilizing MOE training, and also token in, token out, which is very important for agentic training to make sure the chat templates are consistent across turns. For efficiency front, there are also a lot of investment in low precision training in FP4, like FP8, etc. And we also have more recent work in point-to-point RDMA weight sync to make sure the inference engine and training engine's weight sync are much faster. And there are also other focus, like async and pipeline RL, to make sure you have better utilization of your hardware. And there are also MTP and PD disaggregation in inference, which make sure your inference and rollout phase is actually able to make use of all features provided by SGLang. So I'll discuss two highlights here. So one is a problem of training inference alignment, where essentially when people work with different backend in inference and training, for example, when your inference engine is SGLang and your training backend is Megatron, because the choice of kernel being different, and also because a lot of other operations being different, your inference engine's output of log probability output of the same query will be different from the training engine's log probability output. So that makes your entire training run naturally less on policy because of your introduction in the numerical issues between the training and inference engine. So Miles has been mostly focused on actually eliminating such gap by making sure there will be bitwise match log probability output in the training and inference engine. So those are sometimes not only really helpful for debugging purpose, because then you can easily see when your log probability difference in train and inference engine become non-zero, that would mean like you must get something wrong in the entire RL framework. It's also make it easier for people to train in a more online fashion, on policy fashion, for the entire RL procedure. So we have been mostly working on model support of Qwen 3 and Qwen 3.5 MOE families, and which is going to be released soon. And there will be more efforts extending that support for like newer, larger MOEs too. So of course, like there are not just this system way of enabling train inference alignment. There are also more different complementary techniques that can make this makes the gap between train inference less. Where one example would be like routing replay for MOE models, which is also like supported in Miles. And this is a first trial if you are seeing a large gap between inference and training. So you should really try turn on like R3 to make sure all the inference activation will be replayed during training. And there are also like slightly orthogonal technique of token in, token out, which is very important when it comes to agentic training with multi-turn input, because you want to make sure your cross-turn chat template applies well so that there won't be difference in your commonly shared like prefix here. And there are also other techniques that people can make use of for algorithm fix in this train inference alignment. So where people are working on truncating important sampling or max important sampling, those are also techniques that can enable less gap in train inference as a result, because you are trying to fix that using important sampling algorithm during the algorithm design part. So all those efforts combined together are trying to make sure that when training really large MOE models, your train becomes much more stable, and then there will be less loss explosion or like just like reward not going up after a while of training. So most of the techniques here, when used together, they can enable a really much longer training run than like without them like combined here. So the other part of highlight is actually another gap from like Frontier Labs and also open source, which is a low precision RL pipeline, where because of the new hardware's features, people are moving towards more low precision training, but also like when implemented correctly and well, it often comes with like very minimal or even like no like performance loss. So Miles have been really focusing on low precision training, and there have been like unified FP8 training, like and also like FP8 for few layers, and then BF16 for the last few layers. And there are also new exploration on Kimi like in4 quantitative warrior training, and also like MX FP4, like VFP4 training, etc. So a lot of low precision training here are provided as an example in Miles framework, and we are exploring more and more low precision to make the entire training run more efficient, and also like with less performance degradation here. So there have been Miles have been recently like fully supported on AMD hardwares, and we have a recent blog post on AMSys on like ROCm support for Miles, and we have successfully reproduced most of the RL runs on AMD chips. And so today there are a lot of important features that are already well supported on Miles on AMD, like including the basic RL algorithms and also like basically different model parallelism strategy. And we also have like more model support coming soon. So you can easily get the Docker image here and then have a try on AMD hardwares. And here's also like some summary performance on like AMD chips using Miles on Qwen 3 30B MOE models. And then there are some like detailed breakdown provided by the entire run, where you see like the rollout will still be taking more time than training. And then throughput-wise, we have very healthy throughput for both rollout phase and also training phase. And we can see steady reward growing up in both like single-turn mass case and also like multi-turn agentic case. Yeah, so to get started, I'd recommend everyone to try just deploying SGLang and Miles on AMD hardwares. There might be some like small issues with the current link to the Miles Docker, and feel free to refer to Miles document for the most up-to-date ones. And then we'd like to encourage people to try both inference, open source inference, and training on AMD. And any feedback would be really welcome. OK, I think that's pretty much everything I have for today. And thank you for coming. And then we'd love to see your playing with AMD on SGLang and Miles here. Yeah, thank you, everyone.